I sent y'all a copy of this flink environment. So let's go look at this thing here, this flink env. So you see this like copy example env to flink env. So definitely do that. There's going to be a lot of these values will already be covered, and so you don't have to really worry about them. Make sure you have the week 1 and 2 database running in Postgres. Otherwise, this is not going to work. And so you want to make sure that that's running. And you don't like also make sure to pull for the latest version of this repo, because this repo used to be coupled with its own Postgres image, but I don't think that that's important. I think that like just having this be just Flink is the way to go. And so then what you want to do is after you have that flink env kind of put here, right, you'll have, see here's flink env with all of the super secret password stuff, right? Kafka password right there, all these different values here. Make sure you have your IP coding key. You got this from the IP2 location website that I linked in the Discord. Make sure you get your API key and put it here. The code will work without this, but it will be a lot cooler if you put it in. And then obviously you have like the Kafka URLs. These are all the Kafka brokers for my Kafka cluster. And then obviously you have like your Postgres username, password, all these things like how to connect to Postgres. It's not going to work without this stuff. So you want to make sure to have that set up. And then after you have that set up, you want to go to SQL, and then there's going to be this init.sql. And you want to get this processed events table. And go ahead and we're going to copy this table over into our kind of editor here. And then we can run this, right? Obviously, it's going to fail for me, or create table if not exists, right? So it will work either way, and then you'll have your processed events table. So hopefully, if you do everything right here, we will see data in this table after we kind of walk through our Flink job. So before we set that stuff up and we go into Docker, I actually want to walk through the Flink code, and then we can go from there. So in the repo, you'll see there's a SRC folder, SRC job, and then there's 2 jobs. There's aggregation job and start job. So we're going to go into start job, which is going to be the one that we go with first. And what we're going to want to look at here is if you go all the way down, there's this thing called log processing. That's going to be this is essentially like the start of the job. This is where all of our definitions and stuff are going to go from, and we can look and see how this job is actually set up. So one of the things that I noticed when I was working through this, the very first thing you want to do is you want to get this stream execution environment. So you need to give Flink the ability to say, okay, we're doing a stream environment, because Flink can also do like, you can say like enable batch mode. This actually works, right? You can actually throw that on, or I think it might be is batch mode or something like that. This is like, you can definitely, Flink actually understands that, and then it will process things a bit differently. But the default is streaming, so we don't have to worry about it. Then we have enable checkpointing. Let's change this, because this 10 here is actually in milliseconds. So let's go ahead and and multiply this by 1,000 so that we do every 10 seconds, not every 10 milliseconds, because every 10 milliseconds is a lot of checkpointing. That's like too much checkpointing. And then we have, oh yeah, here it is in streaming mode right here. That's okay. We do set it here. So first we have our execution environment, right? Then we have our settings. So these are going to be the settings that will that we want to enable, which in this case we're just saying, okay, use streaming. Then this is what we call our table environment, which is where we can define our sources, which is going to be the table environment is what we're going to use for the rest of the time. So these higher level environments we only use at the beginning. You can kind of think of them as like the Spark context, and then later on you just work with like data frames going forward. And that's essentially what we're doing here. Is this T environment allows us to kind of work more with like what the kind of the Spark equivalent of a data frame is. And then the first thing we do is we do this create temporary function. This is very similar to registering a UDF in Spark. If you know what UDF stands for user defined function. And in this case, we're doing get location. Let's go ahead and look at that function and command click. And you'll see here what this does is get location. What it does is that you have this IP to location URL. This is from that website that we were talking about. And then what this does is it takes in an IP address, and then it uses the API key that you provided, and then it goes ahead and it tries to get the country, region, and city of the data provided. And you'll see that like if you don't give it the key, the request will fail. And if the request fails, it will just return an empty dictionary. So if you don't want to make an account, it's fine, and we'll still get data. It just won't be as cool. And so that's what this UDF does, is it takes in an IP address and it returns a JSON object of country, state, and city. That's what we're going to do with this UDF function. And you'll see it's called a scalar function. The reason why it's a scalar function is scalar functions take in one row or one column, and they return one row or one column. So in this case, we're taking in one column, IP address, and we're returning one column, this JSON object. So that's what scalar means. There's other ones like aggregating function and these other types of UDFs as well that you can work with. But in our case, we are just using scalar function. And if you're not familiar with Python, this is actually how you do inheritance in Python. So our class is getLocation, but it inherits the scalar function functionality. And then all we need to do is implement this. And that allows us to use all the other functions in Flink that are associated with scalar function with this without having to actually implement them ourselves. Okay, cool. That's the getLocation UDF. This is what we're going to use to enrich our data with or enrich our event data with location data based on IP address. So if we go back down here, let's go back to that getLocation call, right? So this is where we're registering get. Location. Great. So then what we want to do is we're going to create a couple different tables. So we're going to create a source table, and then we're going to create two sinks. We're going to create a Postgres sink and a Kafka sink. And our source table is actually a Kafka source. So you see here we say create events source Kafka. So if we go into here, this is where we actually go and define our table. And you'll see, okay, our table name is events. And this is something that is kind of, we have to call it events because that's what I called it when I set everything up. And then you'll see in here, we have our, what are we trying to say here? This is, okay, so then we have a pattern. So I need this pattern to like essentially parse the timestamp because in Kafka, the event time is actually a string, but we want to turn it into a timestamp. And this is the pattern that the timestamp needs. And then what we do is you'll see here, you see this watermark code. This is where it differ. This is like, you'll see that this like initially you're like, wow, this is SQL. And then you're like, wait a minute, this isn't SQL. What the hell is going on with this for keyword, right? This is like a really weird one. So what this is saying is the watermark, essentially, this is giving it that 15-second window I was talking about, right? And that like, so this will fix the ordering of events that are within a 15-second window. And so that is what this watermark is doing. And then this part is so nasty. This took me so long to figure out how to do. But anyways, what is going on with this. Let's talk about each step, each one of these configurations, because I don't want to just gloss over this and be like, yeah, this is how you connect to Kafka. So you know how someone was saying at the beginning of this lecture or the beginning of this lab, are Kafka and Flink connected? They are not, and you'll see this because you see the connector here is Kafka. And say we were using Rabbit, you could also do Rabbit MQ here if you were using a Rabbit connector. Or this can also be JDBC, which is the Java database connector. So you can actually have Flink also read from Postgres or from another relational database. So like Flink can pretty much read from wherever the hell you want it to read from. It's not that big of a deal. And then you have the Bootstrap servers. So these are going to be all of the servers that are running Kafka. This is usually like a cluster of servers that runs Kafka together. And then you have the topic. So you can think of a Kafka topic is very similar to like a database table. And if you look in the Flink environment, in this case, our Kafka topic is bootcamp events. Well, technically it's porcupine 78436 dot bootcamp events, but I couldn't get rid of the porcupine stuff because so I use Heroku Kafka. That's how I set up Kafka because I tried to set it up on AWS and do it all myself, but then I was like, wow, this is a lot of work. So I just decided to use Heroku's Kafka, which worked a lot easier. And so then we have the Kafka topic, which you can think of a Kafka topic and a database table are kind of similar. Then you have this SSL, which worked a lot easier. And so then we have the Kafka topic, which you can think of a Kafka topic and a database table are kind of similar. Then you have this SSL endpoint identification algorithm. This can be HTTPS and other things as well, but Heroku uses key stores. So it uses these four to do the algorithm to identify that you are someone who has authorized access. So we just have to essentially say this is nothing because there's like this weird bug if that happens. So then you have the Kafka group ID. So Kafka can have a group. So you can have you can think of this as like a schema. So you know how like a lot of times in the database world you have like prod dot table name or dev dot table name or the different it's kind of like that higher level grouping. So this can be that's what this is in Kafka. And you'll see that that's, in this case, this is called porcupine 78436. Bootcamp. So that's going to be our Kafka group. That's what we're going to be using for that. And then we're connecting over SSL. So this is actually secure Kafka. And then these ones get kind of gnarly. This is essentially the password and the different trust certificates. If you want to look at these files, they're actually in this. You'll see there's this folder called keys, and you'll see it's like super nasty and encrypted files, right? They're both like really crazy. This encrypted files that you could decrypt with the Kafka password, and then that gives you access to the Kafka database or to the Kafka cluster. I mean, not database. Then after that, we have a couple other things here. These are the last three, and then we have gone over all the million things that you need to connect to Kafka. So then remember how I was talking earlier about how there's latest offset and earliest offset? So what I'm going to do here is I'm just going to sneak in here, and I'm actually going to change this to, we're going to change this to latest offset. And then this can also be latest here. So what this one does, scan startup mode. So this is going to be when you first kick off your Flink job. Is this going to read from the first record in Kafka or the last record in Kafka, right? And then this properties auto offset reset. This is if it fails and restarts. Do we read from the first offset or the last offset? And that's what this is going to do. Or it can also pick up from a checkpoint. So that's a separate thing. So, but checkpointing is optional. So this is required. So even if checkpointing ends up failing, then this will end up picking up where it left off. The last thing is like, okay, how is this data stored? And then in Kafka, this is stored as JSON. You can also put like CSV and TSV and other values in here as well. But the data here is stored in JSON, and that's how my interceptor dumps the data to Kafka. So that's why we have to use JSON here. So this essentially gives us a schema that we can work with and we can play around with. So then what we want to do here is we want to execute the table environment. So the table environment is saying, okay, this table exists and this is how we connect to it. So then this gives us access to this Kafka queue. Great. That's how watermarking works, and this number could be bigger or smaller. I chose 15 seconds, and it is a little bit arbitrary. You can play around with it to kind of understand like how ordering works. But yeah, watermarking is important for out of ordered events though. So Yeah, no problem. Thanks. That was a really great question. So we've defined our source, which is Kafka. Now let's look at our sink here, which is we're going to have create processed events sink Postgres. In this case, right? We actually don't necessarily need this watermark here because we only really need it in one spot. But in this case, we're making another table here. So in this case, what we're doing is we have a table that has a different schema, right? You'll see it has this new geodata column, which is also varchar. But what this does is you'll see the connector here is different. In this case, we are connecting via JDBC. Our URL is our Postgres URL that's defined in that Flink environment. And then we say that our table name in this case is processed events. And then we have our username and password. And then we have the driver. So this is going to be our driver code. And this is something like when you're deploying Flink, you have to include this Java code in your deployment if you want to be able to connect to Postgres. You have to include the driver code as well. Otherwise, this doesn't work. So that is essentially how the sink works for Postgres. This allows Flink to directly access this Postgres table processed events. And keeping in mind, though, that this create table statement does not actually create a table in Postgres. This is just to have Flink be aware of the schema. So that's why you actually have to run that. You know how I said you had to create this create table at the beginning of the lab? You have to run this create table. It's because they're different, right? And so this is just to let Flink know what the schema looks like. So then you have, so that's our Postgres sink. Let's look at the table at the beginning. Allows Flink to directly access this Postgres table processed events. And keeping in mind, though, that this create table statement does not actually create a table in Postgres. This is just to have Flink be aware of the schema. So that's why you actually have to run that. You know how I said you had to create this create table at the beginning of the lab? You have to run this create table. It's because they're different, right? And so this is just to let Flink know what the schema looks like. So then you have, so that's our Postgres sink. Let's look at the last sink, and then we can talk about how each of these things actually works. So then we have the Kafka sink. So here's a Kafka sink. We have process events Kafka, and then you'll see in this case we don't use this pattern because we don't need to because it's a sink. So then we have our sink DDL, which is all of it. This is the same. You'll see this DDL and the Postgres one are the same because these are literally the same. I just wanted to show people how you can write data both to Postgres and to Kafka. And you'll see in this case, all of this is exactly the same as in the source data because it's the same cluster. You'll see the only difference here is actually the topic. You'll see the topic here is a little bit different. It's funky how it works right now. I'm doing it this way where I do this like weird split logic so that we can get that weird porcupine thing out of it that like Heroku gives me, but then I give it the new table name. Keeping in mind that and I'm sad about this because this was something I thought Heroku would let you do, but you can't change this name and create a new topic. Heroku does not let you create new topics on the fly. And then in here, you then can create your topic name and then add it to this big old thing. And then this is then our sink. And this is where we can write data out. And so we now have our sink and we have our two sinks and we have our source. So we have now gotten through the first 5 lines of code of this freaking Flink job. And now let's kind of like actually go to where some of this transformation logic is happening. Okay, so this gives us our Flink Postgres and source table. And you'll see that like one of the things that's really cool is this actually, you'll see this actually just returns table name. So after you create this table, you can actually refer to this table just by its table name, just like you would in a normal SQL environment. And I like Flink SQL for that reason. And that's one of the things that's really cool about Flink SQL, because Flink SQL and Flink Java are going to have like the same performance. And then in this case, what we want to do is we're saying, okay, we're going to add to the Kafka sync, insert into, and then this is what we're going to do is we're going to look at our IP address, right? And we pull the IP address this way because it's like kind of in a nested field, because Heroku actually does this weird like IP address forwarding thing that you need to kind of extract it out. And then we want to do a date field here. So this is essentially moving this back into like a normal timestamp field because it was having a hard time serializing. Kafka was having a hard time serializing this to JSON because it was like a timestamp column, and timestamp has a harder time like serializing to string, but this serializes it back to string. And then we have the referrer, which is like, in terms of web traffic, this is like where they came from, like LinkedIn or Twitter or wherever, right? And then you have the host. In this case, this is like zachwilson.tech or exactly.com or host traffic back column. I was having a timestamp field, a date field here. So this is essentially moving this back into like a normal timestamp field because it was having a hard time Kafka was having a hard time serializing this to JSON because it was like a timestamp column, and timestamp has a harder time like serializing to string, but this serializes it back to string. And then we have the referrer, which is like, in terms of web traffic, this is like where they came from, like LinkedIn or Twitter or wherever, right? And then you have the host. In this case, this is like zachwilson.tech or exactly.com or there's like a bunch of them. And then you have the URL, which is like /signup or /login or /bootcamp or whatever. And then you have you'll see this is actually the get location call. So this is actually calling that UDF that we can then call. You see how we created the get location up here, and then we are calling it in SQL right here, and then we are reading from Kafka. That's essentially what source table here is. And then this is inserting into the Kafka sync, which is the new topic. So we're enriching it with data, and then we're moving it. So then we have the second one here. It's doing literally the same thing, where we are taking it and we are instead moving it into Postgres. and this is going to write records out to Postgres. And you want to add a dot wait here on the last line of your code, our new topic. So we're enriching it with data, and then we're moving it. So then we have the second one here. It's doing literally the same thing, where we are taking it and we are instead moving it into Postgres, and this is going to write records out to Postgres. And you want to add a dot wait here on the last line of your code in Flink. Otherwise, this will just will run for every record that's in the current Kafka queue, and then it will end the job. And this makes it run continuously, this dot wait. So then we have a little try catch here to in case there's a failure for Postgres. And this could also be a failure for Kafka, but like Kafka's probably not going to fail because it's like Kafka to Kafka, which is going to be like less of a bug. So then at the bottom here, obviously you have the actual like the entry point for the job where we actually call the job. So this is the job that we're going to be working with today to actually kind of go over what's going on here to show like, hey, look, we're doing stuff. So then what you want to do, now that we have that working, we can actually go into our messy Docker environment now. So what we want to do here is we want to say make down. I'm going to do make down first, which is we want to kill all of the images that we have up. Then we say make up. Okay, so now our job or our environment is up and running. So let me show you that environment real quick. So if we go to localhost 8081, you'll see okay, so this is our task manager, and you'll see we have no jobs. So this is and here's our task manager. This is where it's running, and you'll see all sorts of different things about like Flink, the memory. You can see all sorts of crazy stuff. But the key thing here is you see there's no running jobs because I just started up the task manager, and let's kind of go over like what's going on here with our slots, right? So we have 3 available slots. So that means I can run 3 jobs at once, but if I have more than 3, then like it's going to wait for one of them to finish or something like that. But our jobs are actually designed to never finish. They're supposed to run 24/7 because they're streaming jobs. But Flink jobs can also be batch jobs. That's why they can finish. That's why some of these have finished, right? So Flink's kind of a wild one where it can do both. So then what I want to do here is say make job. So this is going to call up the the Docker container again, and it's going to see how it's saying, okay, Docker compose exec. We're calling the job manager, and then we're like, okay, we're calling Flink directly, and then we're calling the start job file. And then you'll see, okay, now we have 2 jobs that have been submitted. These are the jobs to write to Kafka and the job to write to Postgres. So Flink is similar to Spark in this way, where you know how Spark, they say Spark is like lazily evaluated, and it only actually fires up a job when like there's like an insert statement or a collect statement, or there's like a movement of data. Flink is very similar like that, and that's why there's 2 jobs that end up getting fired here, and that's because of these insert statements here. These insert statements cause 2 jobs to be fired, and that's what's going on. If y'all like are curious about like why there's 2 jobs instead of like 1 big job. So you'll see here now we have 2 jobs here that are running, and if we let's go into this processed events. So if you look at this guy, this is going to be our code here. And you'll see it's going pretty well. Back pressure 0, busy 0. Because if you remember, I changed the source to be you see how I changed the source to be latest offset. So it's only reading in new data. So like let's like load up a row. Okay, so that's going to cause it to have at least 1 row of offset. So it's only reading in new data. So like let's like load up a row. Okay, so that's going to cause it to have at least 1 row of data. That let me go into here real quick. Let me delete the data here first so that we can see the new data. So okay, so I deleted the data from processed events. And let's add 1 more record to the queue. And then what we want to do here is if we go back here and we say select star from processed events. Okay, so you see I have 1 record here. And see here. There is US, California, city, San Francisco, right? So, and if any of y'all freaking want to like go to zackwilson.tech, you'll see that your data and location will show up here. And obviously I live in San Francisco, so this is actually pretty good and kind of creepy. All right. I was able to go to zackwilson.tech. You'll see that your data and location will show up here. And obviously I live in San Francisco, so this is actually pretty good and kind of creepy. I was able to do this. And so the idea here is, if you see, I can go to other pages too. So if I go to like boot camp, right? Oh, let me go to exactly boot camp. It's like, because I'm like logged in over here. Okay, there we go. So now you'll see I should have generated a bunch of events there. So if I like put a limit, let's put limit 10 here. So there we go. Oh, and some of y'all were like refreshing stuff too. So you'll see, oh, look at that. Look, Bruno. I think this is Bruno. I guess this is Bruno here. Brazil. What's up? Everyone else. Do we got representation here? Oh, dude, we got a lot in here. We got some Florida. Got some Alaska. Look at that, dude. I got some freaking people in here. Here's got some Texas, right? So Sugarland, Texas. Interesting. It's a cool place. So anyways, you'll see but you see how all of this data was just available immediately, because that's what real time's all about, is it's immediately available. That's what it's all about. And you'll see this guy here actually, you can see some of these people are actually coming from different spots. Like this guy came from my Substack. So this is actually probably an event that was not from the bootcamp, because you see like there's a referrer here that is my Substack. So they came from my Substack newsletter. And you can see, oh, that's kind of like how all this is working, right? And this is the idea behind how this works. But like what you can do, right, is you'll see with the geodata. So if we like geodata and we JSON and then we say country, right, then we can like, there we go. And then we can also then count. One, and we can say what group by one. There we go. Then you can see all the different countries. So we got US as leading, we got Nigeria, we got Canada, and we got Brazil, right? We got a couple of people showing up from all over the place here, right? And this is essentially what's going on, but it's in real time, right? So like as more data comes in, see, there's another one. See, now we have another one, VE. Is that like Venezuela? I have no idea. But like you'll see, like this is a live data feed, right, of this processed events, because my Flink job is just processing new data as it comes in. And so this is pretty cool. So one of the other things this job is also doing, right, because there's two jobs here, right? So if we saw here, so you see processed events Kafka, you see it was here at this like 39.67 megabytes. And you see how like now it's a little bit higher. What we saw here, so you see processed events here, right? So if we saw here, so you see processed events Kafka, you see it was here at this like 39.67 megabytes. And you see how like now it's a little bit higher. It got moved up to this 40 megabytes, and now it's like slowly growing. And like, so that's what's going on with this process events Kafka, because we are writing more data to this Kafka queue as it comes in, as like more and more people like, you know, spam my website and stuff like that. And so this is kind of the idea behind how Flink works. Is you have kind of different values that can come into place here. So one of the things I want to show real quick, though, is I'm going to kill these jobs. Real quick. So I'm gonna say so the jobs are killed, and I'm gonna say make down. I'm just gonna kill the whole. I'm gonna start over here, and what I want to do here is I'm gonna change this to earliest, just to kind of show you the difference, right? So you'll see here when we ran that, what there was like, see how there's like, I don't know, like 50 records, because that's like how many people hit the website in the last like 5 minutes. But now when I run it this time with earliest offset, if we go look at the Kafka dashboard, so ours is bootcamp events. So this is going to be our actual data set that we are working with, right? So this data set is like about 15 megabytes. So I would hope, like if we use earliest offset, we're going to process all of this data again. It's going to process all the way from the beginning. And that's like what we're going to do when we redeploy this job here. So in this case, we're going to say make up. Okay, so now what we want to do is we want to then say make job. And then I'm going to show, this is going to create some interesting things in the UI that I want to also illustrate to y'all so that you can understand some other kind of pieces of this puzzle. So There we go. We have our two jobs running. So now let's go back into the Flink UI while we can still show what's going on here. So let's go look at this process events job. And you'll see, one of the things you'll see is like, you see how it's like red right now? And it says it's very busy. It's 64% red. And so what's going on here is it's busy because of the fact that it's, oh, there we go. Now it's really red, right? So now it's like really busy. Now it's like essentially maxed out. So what happens here is you have, you see how there's like busy and then there's back pressured. So these are two different kind of things that can happen because, so busy means, okay, we are at max compute. Like this Flink job cannot process any more data. And if it processes more data, it gets moved into back pressure. And essentially back pressure is the second layer, where back pressure essentially says, it tells Kafka, slow down, because we need to essentially add a little bit more latency to the data so that we don't out of memory, and so that we can process all the data that's coming in. And this can happen like, you know, if your data set goes very viral, or if your data set is like if you get a lot of hits, it's very spiked, or you get some spiky data sets, because you can't necessarily manage that yourself, because you can't just be like, oh, I'm going to stand up more Flink machines. Obviously, you can set the parallelism and have like do distributed compute with Flink as well, but you have to pick the number of machines ahead of time, and you don't know how much data is going to come in. You could have more, could have less, right? So that's essentially what's going on here, right? Is now we have our data and it's essentially running, right? You'll see now I bet it's back to, okay, so yeah, it's still processing stuff. It's still dumping everything out. So this is kind of the idea behind how this stuff works, is we have our back pressure and our busyness of our job. And you'll see the Kafka one is the same way, right? It's just maxed out, like it's just trying to struggle through it. And then eventually it will like be essentially go from like 100% to 0%, because it's just going to finish everything, and it will have processed everything. But now if we look at like this query here, right? So remember, like we had like 50 rows here, right? I bet there is a lot more than 50 now, right? Oh yeah, look at that. Look at that. There's a lot more than 50 now. So now we have like, okay, see, we have our US, we have India, Great Britain, Canada, whatever IE is. Japan, right? All these different countries here. Even some that didn't even, you have null here. So that means that some of these IP addresses didn't geocode correctly, or they have like there's like a null, right? But you'll see like, I don't know, there's 44 different countries. So people in 44 different countries have visited my website in the last day. And that doesn't, I mean, it might not even be done, right? Let's, if we put like it should keep processing. There we go. So you see how it's still struggling through, right, all of the data here. And that's one of the things that is tricky about Postgres syncs. So Kafka syncs are generally a little bit more performant because of the fact that they are meant for high throughput, because you have like the queue can just be dumped in and it's fine. Whereas Postgres is not, right? Postgres is more meant for like transactional data that is like kind of not large volume, right? It has like and so you want to be aware, like when you're building out your Flink jobs, like where is the data going, and like what, this is wild. This is not supposed to be so busy. Why is this so busy all the time? Like y'all need to like quit visiting my website. Like last time, that just shows you, like, because I did this same presentation back in May, and like it was busy for like a minute, and now we're rocking almost 4 minutes now, guys. Like, so this is madness. But like this is the idea behind like how you kind of build Flink jobs. But the key thing I was trying to say here is back to the syncs, right? So Kafka is going to be a very high throughput sync that like can manage things a lot more effectively. So I imagine that the Kafka dump here is going to end up being not busy a lot sooner than the Postgres one, just because of the throughput of Kafka. And then that's kind of the idea behind how these jobs work.
Congrats on getting to the end of Streaming Data Pipelines Lab Day 1. Streaming pipelines are crazy, right? If you're taking this class for credit, make sure to switch over to the next tab so you can get a credit for Day 2. I hope you enjoy it.
I wanted to talk a little bit today about what is actually going on underneath the hood of, like, you saw how, like, on Tuesday there was we have this Kafka thing that, like, you hit a website and then data just shows up in Kafka, right? And so I wanted to kind of explain, like, more in detail of, like, this right here is the architecture of my entire website. So let's start over here with, like, stick figure man. So this is, this is you or a student or anyone who's visiting my website. And then the first thing that happens is you'll see that, like, if I want to go to exactly.com, what happens is that request gets intercepted. So there's this HTTP interceptor, and what that does is it just looks at the request and then it logs it down to Kafka, and then then it also just passes it forward. So then exactly.com can then determine what to do with that request after it hits the server here, hits Express. But then, like, okay, when that request gets logged down, it goes to Kafka, it goes to a Kafka producer, and then that Kafka producer puts it on Kafka, and then we can then read from Kafka onto Flink, and then we can either dump it to another Kafka topic, which is what res is the response, and next is how, if I call next, that means it passes the request to the server. So what happens here is first I have this message to this table, and then I have my message object, which is next, which means that, and then in my server. Okay, so then we have the producer code. So this is the producer code. Or you saw how, like, here we have that send message to Kafka in the interceptor. Well, here is that send message to Kafka, and then I create this Kafka producer here, which has a similar sort of SSL connection, like like we do in Flink, where we have to connect with, like, all those, like, SSL credentials, because we need to do that on the producer side as well. And then you'll see here I'm saying, okay, write to this Porcupine Bootcamp events. So this is that topic where, like, I want to write this message to this table. And then I have my message object, which is essentially just the object that I have over here, this event object. I'm going to be writing that. And then what we do is we start up the producer, and then we send the data to the producer. And then this producer So this Kafka consumer is just listening on this processed Kafka queue. And then what will happen is this consumer will then push events. Like there's like you can dive and all the other kind of data lake kind of architectures. It returns its result, each one of those like in detail. So like, I don't know, 7, something from point A to point B. And then everyone in that window is going to be in that time, 50% overlap. So we can kind of see, I'm just going to copy this. Just a window time. That's the, we're going to call this a window timestamp at the, like this many records, right? And it's like, and this must just be like spare traffic that like, it's not all the data sequentially. Task slots here